I'm Dr. Ara Digmajan with Prime Coral Labs, and in 2018 I discovered that coral RTN was due to a protozoan parasite that lives within the coral gastrovascular cavity and under its tissue, and that parasite is Philaster. There are two types of Philaster, Philaster guamans and Philaster lucida, and I don't specify when I talk about what causes RTN because they both do. Philaster itself, and there are two subspecies, guamans and lucida, they cause coral RTN. Now, one of the telltale signs of coral RTN from Philaster is that the skeleton itself will turn a greenish color. This green is not algae. This green is actually staining of the skeleton from the cytoplasmic contents and basically dyes that are within the cell of the protozoan, within its cytoplasm. The cytoplasm is what's contained within the cell walls. This is a single cell organism. It's microscopic. You can't see it with your eyes. The only way to see it is with a microscope. So when it dies, it basically releases a dye within its cytoplasm that's kind of green-brown, and that dye gets there from digesting zooxanthella. That's what this organism eats. It actually eats coral tissue to get to the zooxanthella. And then if you look at their bodies under the microscope, you'll see anywhere between 10, 20, 50, or 100 zooxanthella within each one of them, depending on how mature and old each cell is. Some of the protozoans can live for probably, I estimate, about a month or two, and the older ones are bigger and they hold more zooxanthella. It appears that they use the zooxanthella to make energy. I think they use it somehow and feed off the sugars that the zooxanthella make. Anyway, as they also digest the zooxanthella at times, maybe when they're not getting enough food, and as they digest the zooxanthella are a brownish gold color, and this is what I believe is the byproduct pigment, and it stains the skeleton. So this coral was a brown coral for a long time, and it was brown because it's filled with Philaster, literally tens of thousands of them, and they basically steal the energy of the coral, and the coral can't produce pigments that make a normal coloration of a coral. So this is actually an orange millipore. It's absolutely beautiful, and it's been brown like this for the last 6 months. I've been hoping it would color back up, but it did not, and it's actually RTN. So it's had it, it's thrown the towel in. The Philaster have finally come out and started to eat the tissue at the surface. They've come out of all the little pores, but you can see they've been there a long time, and basically that's all their, I would say, fecal matter that's staining the skeleton, but the dyes within each organism. This coral RTN, we're going to throw it within a urine cup, and we'll look at it tomorrow and see how many Philaster are actually in it. Another coral as well had RTN. It started to RTN right here in the back, and it also has a slight green color to it. So I'm going to put both of these corals together in a pea cup with a little bit of water, and we'll look at them tomorrow and see what's swimming around.